Good day, students. Welcome to mathgotserved.com, and this clip we're going to be going over how to solve binomial equations. Alright, the instructions for the example that we are going to be working on is as follows. We are to solve the given equations. Alright, let's take a look at the first example. Let's say we have the equation 3x squared minus 8 equals 0. Alright, so the first thing we're going to do whenever we want to solve binomial equations is we want to ask ourselves, is there a greatest common factor that can be factored out from both terms? Okay, so is there a greatest common factor that can be factored out here? Clearly we can see that there is no common factor in these two terms that we can factor out, so we're just going to go ahead and solve. Alright, to help you see that there are no common factors, you can go ahead and decompose the two terms. So you have 3 times x minus, if you decompose 8 using a factor tree, you have 2 times 2 times 2 equals 0. And as you can see, there are no like terms for these two terms that we have here. Okay, so we're going to combine them back together. 3x squared minus 8 equals 0. Alright, let's go ahead and isolate x. We're going to be adding 8, dividing by 3, and taking the square root to solve this particular equation. Alright, so let's go ahead and do it. So first things first, we're going to add 8 to both sides of the equation. So that gives us 3x squared equals 8. And then we're going to proceed to divide both sides by 3. So divide by 3, divide by 3, and that yields x squared is equal to 8 over 3. Okay, now to get rid of the square, we're going to use its inverse, which is the square root. So we take the square root of both sides, and since we have a fraction here, we're going to root the numerator and the denominator independently, okay, because we cannot have a fraction as a radicand. Rooting them separately will enable us to rationalize with ease. Now what do we have next? Anytime you take the square root of a square, you have x. Don't forget to insert the plus or minus components on either side. I'm going to put it on the right side since I'm getting x isolated. So we have plus or minus root 8 divided by root 3. Now we can't have a radical in the denominator, so we're going to proceed to rationalize the denominator. Okay, so we're going to multiply the numerator and denominator by root 3. The goal here is to create a perfect square in the radicand in the denominator, so that will take out the square root in the denominator. Alright, so we're going to have x equals plus or minus. Now the square root of 8 times the square root of 3, what you do here is you multiply the radicands, which gives you the square root of 24. And then in the denominator, if you multiply root 3 and root 3, that's root 9. The square root of 9 is 3. Okay, now let's go ahead and simplify this radical component that we have right here. We want to simplify root 24. Okay, so we're going to use a factor tree and extract any perfect square from the radicand. So what goes into 24? Prime numbers that go into 24. 2 goes into 24 12 times. This is even, so 2 goes there 6 times, and then 2 6 2 3. Okay, so any factor that repeats itself, that was considered a square, and it can come out as its root, which is just one of the factors. So as you can see here, 2 times 2 is a square, namely 2 square. What is the square root of 2 square? The square root of 2 square is 2. These two numbers here are not repeated, they are not squares, so they stay behind in the radicand position. So the square root of 24 is basically 2 comes out root 2 times 3, which is 6. Okay, so we can rewrite this answer in its simplified form as x equals plus or minus 2 root 6 divided by 3. Alright, and if we want to write it using a set roster notation, our solutions are going to be squiggly bracket negative 2 root 6 over 3 and positive 2 root 6 over 3. Okay, so these are the solutions to the original binomial equation. Alright, let's take a look at another example. Let's say we have the binomial equation 5x to the 4th power minus 80 equals 0. Okay, so let's go ahead and solve this equation. Alright, so what we're going to do, first of all, as we did in the previous problem, is ask ourselves the question, can we pull out a greatest common factor? As you can see, 5 is common to these two terms, right? So 5 can be factored out. But let me just show that to you so it's clear. We have 5 times x, 4 x's. And then if you decompose 80, you can factor out a 5 out of 80. 80 divided by 5, 5 goes into 8, 1. Remainder 3, 5 goes into 36 times. Okay, so it's 5 times 6 equals 0. Now, as we can clearly see, there is a common term, a common factor, namely 5, that can be factored out. Okay, so we factor that out. We have 5 is as though we're dividing by 5. We're going to be left with 1, 2, 3, 4 x to the 4th minus 16 equals 0. Okay. Alright, so now if we take a look at this quantity in the parentheses, this is known as a difference of squares. I also refer to them as doses. Okay, dose, difference of squares. Now, how do you factor out those expressions? So, difference of squares, this is how you factor them. Okay, so if you have a square minus b square, this is an example of a difference of squares. How you factor this dose is you take the square root of the first and last term and express the roots as a sum and difference. Okay, so the factored state is going to be a minus b times a plus b. Okay, so we're going to apply the same principle here. X to the 4th is a square because the power is even. Any term with an even power is a square. Okay, and 16 is a square because 4 times 4 is 16. So what are we going to do here? We are going to proceed to take the square root of the first and last term. Remember, they have to be a minus in between. Okay, it has to be a difference of squares. This is difference. Express that as a sum and a difference. So the factored state is going to be 5 times the square root of x to the 4th is x squared minus 4, which is the square root of 16 times x squared plus 4 equals 0. Okay, now let's inspect these two quantities here to see if we can factor further. Take a look at x squared minus 4. What do you notice here? That's another dose. This is another difference of squares, so we can factor that. Okay, so we have 5. To factor that out, we are going to do the same thing that we did here with x to the 4th minus 16. We're going to root the first and the last term and express the roots as a sum and a difference. Okay, so we're going to have x minus 2 times x plus 2 multiplied by, now let's take a look at x squared plus 4. X squared plus 4 is a SOS. What does that mean? It's a sum of squares. How do you factor out sum of squares? With real coefficients. The factorization of this doesn't have real coefficients. Okay, so if you want real coefficients, this is considered to be prime. It cannot be factored with real coefficients. You have to insert an imaginary number there. Alright, so we're going to leave x squared plus 4 alone because it's a sum of squares or a SOS. It's only the difference of squares that can be factored in order to have real coefficients. Alright, so what we're going to do now is we're going to see, oh, there's a 5 here. This 5 can be, you can divide out constants. Okay, don't divide out variables. This 5 can be divided. We can divide both sides by 5, so divide this side by 5 and divide by 5. So that gives us x minus 2 times x plus 2 divided by, times x squared plus 4 equals 0. So remember, you never divide by a variable term, okay? Okay, now we're going to use something called the zero product property to proceed. So that involves setting each factor to 0. Okay, so we'll set the first factor to 0, the second factor to 0, and then the third factor, set it to 0. To solve the first one, we add 2 to both sides, and that gives us x equals 2. That's the first solution. And then in the next one, we are going to proceed to subtract 2 from both sides, and that will give us x equals negative 2. And then the last one, we're going to subtract 4 from both sides, and that will give us x squared equals negative 4. And then to get rid of the square, we use the inverse operation, which is the square root. So we square root both sides. Okay? I will take the square root of both sides. We're going to have x equals, now when you square a negative, if you root a negative number, that minus comes out as an I, and then the square root of 4 is 2, so we have 2i. Alrighty? Now does this answer look complete? This imaginary set of answers we have here. The answer is no, it's not complete. Now what's missing? Remember earlier it was indicated to us in the first example that when you take the square root of a square, as we did over here, what did we add on? Plus or minus, right? So the same principle applies here too. Since we took the square root of a square, we have to add the plus and minus components. That is because when you square a negative or a positive number, you end up with the same square. Alrighty? So these are our roots. Let's write our solutions in set roster notation form. So our solutions are going to be, let's see, negative 2i is the first one, 2i is the second one. These are the imaginary roots. And then the real roots are negative 2 and 2. Okay, so these are the solutions to the original binomial equation. Alright, let's go ahead and take a look at question number 3. Now let's say we have the binomial equation 16y to the 4th minus 9 equals 0. Okay, so we want to carry out the same procedure. We have to solve this equation. So 16y to the 4th minus 9 equals 0. Alright, first things first, let's see, is there any common factor that can be taken out of these two terms? Let's break it down. 16 is 2 times 2 times 2 times 2 using a factor 3 times 4y's. And then if you break down 9, you have 3 times 3. As you can clearly see, there are no common factors that can be extracted. So we're going to combine the numbers back together. 16y to the 4th minus 9 equals 0. Now what do you notice about 16y to the 4th and 9? They are both squares, okay? And then the sign in between them is a minus, so we have a dose situation here, a difference of squares. Alright, so remember the rule for factoring doses. Difference of squares, if you have a square minus b square, what do? You take the square root of the first and the last term, and then express the roots as a sum and a difference. Okay? So the sum and difference of the square root of the squares. So we have a minus b times a plus b. We're going to apply that principle here. So we're going to take the square root of the first term and the square root of the second term and express it as a sum and difference. Alrighty, so that gives us square root of 16 is 4. We have 4y. To root y to the 4th, what you do is you divide the power by 2. Okay, so 4y squared minus the square root of 9, which is 3. That's times 4y squared plus 3 equals 0. Alrighty. Okay, now that we have it factored, the question is, can we factor any further? And the answer is no, because this, even though this is a square, 3 is not a square, so we can't factor this, okay? So what we're going to do now is we're going to use the zero product property and set both factors to 0. So 4y squared minus 3 equals 0, and 4y squared plus 3 equals 0. Okay? So for the first one, we're going to add 3 to both sides. Okay? And that will give us 4y squared equals 3. We're going to proceed to divide both sides by 4. And then we have y squared is equal to 3 over 4. Now, how do we get rid of the square? We use the inverse of a square, which is the square root. So we root this. We have a fraction here, root the top and the bottom. Okay, and then we have y. Don't forget the plus or minus. Plus or minus the square root of 3. And then the square root of 4 is 2. Like that. Okay. Now let's take a look at the next equation. For this one, we're going to subtract 3 from both sides. And then that, what does that give us? That gives us 4y squared equals negative 3. Going to divide both sides by 4. Okay, and then that gives us y squared is equal to negative 3 over 4. To get y by itself, we're going to proceed to do exactly what we did here, which is the inverse of square. We're going to root both sides of the equation. On the right side, we're going to root the numerator and denominator separately. And then that's going to give us y equals plus or minus square root of negative is I, and then root 3 cannot be simplified, right? So we're going to have I root 3, and then the square root of 4 is 2. Okay? So our solutions are as follows. Our solutions are negative root 3 over 2i, positive root 3 over 2i, negative root 3 over 2, and root 3 over 2. So those are the solutions to the original equation. Alright, let's take a look at one more example. Number 4. Let's say we want to solve the equation x to the 6th minus 1 equals 0. Alright, so the solution is as follows. So we have x to the 6th minus 1 equals 0. We can clearly see that there are no common factors that can be extracted here. So what we're going to do is we're going to go ahead and factor this, okay? Now, if you take a look at what we have here, you notice that we have a difference of squares. Do you see that? X to the 6th is a square because the power is even, and 1 is a square because 1 times 1 is 1. Alright, so we have a dose situation. Let's write the formula again. So for dose, we have a squared minus b squared equals a plus b times a minus b. Let's use the minus one first. It doesn't really matter, but let's just say we have a minus b times a plus b. Okay, and remember that the sum of sum of squares cannot be factored. So if you have an SOS, sum of squares, a squared plus b squared is prime. Alrighty, just FYI. So what we're going to do here is we're going to root the first and second term like we did in the previous examples, express it as a sum and a difference. Okay, so we are going to have x to the divided power by 2 third minus 1 times x to the third plus 1. Ladies and gentlemen, we have a difference of cubes and a sum of cubes. A duck and a sock. Okay, so we have formulas for those. Unlike the squares, you can only factor the difference, but for cubes you can factor both the sum and difference. Okay, so let's do the doc first. Difference of cubes. For the difference of cubes, you have a cubed minus b cubed. We're going to use the SOAP formula. Okay, so we have a, the first sign is always, so for SOAP helps you remember how the signs work. Okay, so the first sign is always the same. The second sign is opposite, and the last sign is always positive. Okay, so we're going to use SOAP to guide us. Alright, so the first sign is going to be the same as this sign right here, which is negative, a minus b. A squared, the next sign is going to be opposite, which is plus ab, and the last sign is always positive. So this is the factorization of a difference of cubes. Okay, difference of cubes. Guess what? Unlike squares, as indicated earlier, the SOCs can be factored also. Even though you have a sum or a difference, it doesn't matter, it can be factored too. So we're going to use the SOAP formula again. So same, a plus b. A squared, the next sign is opposite, so this is plus, so this is going to be minus ab, and the last sign is always positive. Okay, so we're going to use this formula as to factor x cubed minus 1 and x cubed plus 1. Okay, so for the first one, you can clearly see that a is x and b is 1. This is a cube because 1 cubed is 1. So if we apply this formula here, a is x and b is 1. We are going to have a minus b is going to be x minus 1 times a squared is going to be x squared minus ab is x times 1, which is just x, plus b squared, which is 1 squared, which is just 1. Okay, and then for the next one, the same principle applies. A is x and b is 1. So we have a plus b, x plus 1, times a squared, which is x squared, minus ab right here, minus ab is minus 1x plus b squared. Okay, alright, so that's equal to 0. Now what we're going to do is we're going to set all the factors to 0 using the zero product property. So let's take the linear factors first. X minus 1, set that to 0. Easy. X plus 1, set that to 0. Easy. And then we have the other components, x squared minus x plus 1. Set that to 0. And then x squared minus... okay, wait, we made a mistake here. So for the x cubed minus 1, this is supposed to be a positive because the first sign is the same, the second sign is opposite, so it's opposite of that sign, and the last is always positive. Okay, so for this one is the same, the second sign is opposite, and the last sign is always positive. Alright, so let's fix that. This is a plus, and this is x squared minus x plus 1 equals 0. Alright, so to solve the first two is pretty much straightforward. To solve the first two, you just for the first one, you add 1 to both sides. Add 1, and then you have x equals 1. And then for the second one, you subtract 1 from both sides. And then you have x equals negative 1. Alrighty. Now here we have a quadratic equation. Let's see if we can factor it. Okay, so let's make our x. AC goes on the top. AC is 1, B is 1. Alright, so here A is 1, B is 1, C is 1. So AC and B goes on the bottom. Alright, so let's just put a side note here. A is 1, B is 1, and C is 1. So think about two numbers that multiply to give you 1 and add to give you 1. The only two numbers that you can multiply to get 1 integers are 1 times 1, and 1 plus 1 is not 1. Okay? So this expression on the left side is prime. It cannot be factored. Okay? So since it cannot be factored, we're going to use the quadratic formula. Alright? Hopefully remember what that is. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you forget it, you can always sing the quadratic formula song to remind you. Alright, so let's do it. So the for this one right here, the first factor, we're going to have x equals negative b, which is minus 1, plus or minus the square root of b squared, which is 1 squared, 1 minus 4ac, 4 times 1 times 1 is 4, and this entire thing over 2a, which is just 2. Alright, we're going to simplify this using the order of operations. So we have x equals negative 1 plus or minus the square root of negative 3 over 2. Okay, and then we can simplify a little bit further. This becomes x equals negative, we can break it up, 1/2 plus or minus, now the square root of the negative is I root 3 over 2. So these are the answers for the second one, for the third factor. Okay, alright, let's take a look at the last one, the last equation. Let's see if we can factor this one. So for the last equation, a is 1, b is negative 1. In this one right here, b was 1, but here b is negative 1 and c is 1. Okay, ac goes on top, b goes on the bottom. ac is 1, b is negative 1. So what two numbers multiply to give you the top and add to give you the bottom? The answer is there are no such numbers that satisfies that condition. You can't think of any two integers that multiply to give you 1 and add to give you negative 1. This expression we have here is prime. It cannot be factored. Okay, so if you cannot factor it, you can solve it using the quadratic formula or completing the square method. We're going to use the quadratic formula as we did in the previous equation, which is this one right here. Okay, so using the quadratic formula, x equals negative b. So in this case, instead of it being negative 1, it's going to be negative 1, which is positive 1, plus or minus the square root of b squared, negative 1 squared is 1, minus 4ac, 4 times 1 times 1 is 4, all over 2a. 2 times 1 is just 2. Okay, let's simplify. X equals negative 1 plus or minus the square root of 1 minus 4 is negative 3, all over 2. Simplify a little bit more. X equals oh, there's no minus there. I just put in a minus out of thin air, so it's positive 1. Alright, so x equals 1 over 2 plus or minus. Now the square root of negative comes out. The square root of negative is I, plus or minus I root 3 over 2. So there goes your last two answers. Alrighty, so let's go ahead and write our answers using the set roster notation. So we have the solutions are x is going to be, let's do the imaginary roots first. Okay, negative 1 over 2 minus root 3 over 2i, negative 1 over 2 plus root 3 over 2i, 1 over 2 minus root 3 over 2i, 1 over 2 plus root 3 over 2i, negative 1 and 1. Okay, we have 1, 2, 3, 4, 5, 6, 6 complex roots. 4 of them are imaginary, 2 of them are real. Okay, so that's that. Now, how well did you master the contents of this presentation? To demonstrate mastery, we would like you to try out these problems. Okay, so try these. Instructions are still the same. Solve the given equations. For number 1, let's say you have the equation 4 plus 9x squared equals 0. Number 2, what if you have 2x to the third minus 5x equals 0? Number 3, What if you have 16x to the fourth minus 16 equals 0? Number 4, what if you have 81x to the sixth minus 16x squared equals 0? And number 5, what if you had 3x to the seventh minus 192x equals 0. Alright, go ahead and pause this video at this time, try out these problems. When you're done, click on the playback button to see what the answers are. Alright, welcome back. Hopefully you had a chance to try the problems. The solutions are as follows. For number 1, we have negative 2 over 3i and 2 over 3i. You notice that the imaginary roots come in pairs, namely opposites of each other. Number 2, our solutions are negative root 10 over 2 and 0 and root 10 over 2. For number 3, our roots are negative I, and of course its opposite, I. We have negative 1 and 1. For number 4, we have negative 2 over 3i, and of course its opposite, 2 over 3i. We have negative 2/3, 0, and 2/3. For number 5, we have 1, or let's do the negative one first. For this one, we have negative 1 minus root 3i, negative 1 plus root 3i, 1 minus root 3i, and 1 plus root 3i. Alright, these are the imaginary roots. We have some real roots, which are negative 2, 0, and 2. Alright. So how well did you do on these problems? Let us know by posting a response in the comment section below, and let us know any complications or confusions that you had in the try these problems. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of solving polynomial equations, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just post it in the comment section below. We'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other presentations such as this. We upload videos to our website on a regular basis. More support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.